At the top of your paper right now, write Trig Identities. That's what we're going to do. We're going to do an intro to this. So we have Trig Identities. We're going to start off by looking at this thing. We want to see how can we rewrite all of these in terms of a positive theta. Just to make it a little bit easier, I'm going to draw theta right here. And so this says negative theta. It really doesn't matter what quadrant it is in. It will work in any quadrant at all, but just this will make it a little bit easier. And then we say, all right, where would a positive theta be? That would be up here. So when we draw these down, just like the multiple times we've dealt with these, we can prove that these two triangles are congruent. That's not too difficult here. You could say we have a right angle here, we have these two angles are congruent, and we have the hypotenuse, since it's a circle, of radius 1. And so we could say angle, angle, side, angle, angle, side. All right, so we have two triangles that are congruent. How do we compare? What is sine on the unit circle? Sine is a y value. How does this y value compare to the top one? They are opposite in sign, so it's negative sine of theta. Let's look at the cosine. The cosine is the x values. Those are the same, so it's cosine of theta. What is tangent? Tangent in the fourth quadrant is negative, and in the first quadrant it's positive. That's one way to look at it, so you could say it's negative. We could also write it, and I'd like you to write this one down. Some people are still not clear on how to change tangent into sine and cosine with that angle. It would be done like this. Well, that's negative sine of theta, because we just did that in the first part, over positive cosine of theta. So that's negative tangent of theta. Now, some might be thinking, oh, this is the same as reference angle. It's not the exact same thing as reference angle. It's very similar, though. If sine is opposite in sine, the reciprocal, that will also be opposite in sine, so it would be negative cosecant of theta. And we could do that just the way I did tangent as well, saying 1 over sine of negative theta. And this would be the same as the cosine in terms of being positive, so this would be secant. And cotangent would be the same as the tangent, negative cotangent theta. Now, just to show you, this negative theta could be over here. And then the positive, this would be negative theta. The positive theta would be here. And right now, I'm assuming that theta is positive, and it really doesn't matter. But again, we would have our two triangles are congruent. The x values would be the same. The y values would be opposite. Okay. Write the equation of a unit circle. We haven't worked with the equations very much. X squared plus y squared equals 1 squared, or 1. It's a unit circle, so it has a radius of 1. Now, replace x and y with the appropriate trig functions. What is x equal on the unit circle? We have our theta. We have a point here, x comma y, and we have a radius 1. So this piece here is y, and this is x. And we know that x equals the cosine of theta, and y equals the sine of theta. So we can say cosine of theta squared plus the sine of theta squared equals 1. Now this is rewritten as cosine squared theta plus sine squared theta. Now, for whatever reason, they always move sine into the front. So it's sine squared plus cosine squared equals 1. And that is an identity that we need to know. From this, we can get two other ones. So rewrite that equation. Now, there's one identity that has tangent in it. What is tangent? Tangent is sine over cosine. So what could I do to this to get tangent? I'm going to have to divide by cosine here, and since this is a squared, I'm going to divide by cosine squared. So divide each and every term by cosine squared, and what do we get? Sine squared over cosine squared would be tangent squared, plus 1 equals secant squared. And then take that same identity, and this time let's derive the one that has cotangent squared in it, and cotangent would be cosine over sine. Oh, I think I already wrote cotangent. That should be cosine. So we're going to divide by sine squared to everything. And so this gives us 1 plus cotangent squared theta equals cosecant squared. These are called the Pythagorean identities. And it has that same basic thing of a squared plus b squared equals c squared, except our c here is 1. You got to know these things. The key here is the first one, because you could always figure out this second one pretty quickly. All right, let's take a look at the next part. Take out your trig chart. What relationship do you notice between sine theta and cosine theta in the first quadrant? For what different values in the first quadrant does sine equal cosine? List them. Now, it is up to you to do this. So give me two values. Try to think of two values here where the sine of one value, for example, the sine of 30 equals the cosine of what number? It's a cosine of 60. The sine of 45 equals the cosine of 45. The sine of 60 equals the cosine of 30. And here, what if I said the sine of 0? That would equal the cosine of 90. What if I gave you the sine of 5? That's not in the unit circle. That would be the cosine of 85. So what's the relationship between there? The sine of theta equals the cosine of 90 minus theta. Similarly, though, you could do the same thing for the cosine. The cosine equals the sine of 90 minus theta. And we could treat these the exact same way in terms of 1 over sine would equal 1 over the cosine of 90 minus theta, and 1 over cosine is secant of 90 minus theta. And so what happens here is they all will apply in the same way. And this is cosecant of 90 minus theta, and then tangent would be the cotangent of 90 minus theta, and cotangent would equal tangent of 90 minus theta. Now, these are known as co-function relationships. Now, what I want you to do is I want you to tell me what does the co mean. Think about that and tell me tomorrow in class. You can write that over here to the right. What does that co mean? Think about, look at the relationship here. And what do you think co means for those? All right, the next one. Simplify. What we're going to do is simplify these expressions. We're going to have to be able to manipulate them. When I see sine, okay, that's just sine. There's nothing to do with that. Tangent of 90 minus theta. We should immediately think, oh, that's one of these co-function relationships. Well, that would be cotangent of theta. Now that's one step. We're not quite done. What is cotangent of theta? Cotangent of theta is cosine of theta over the sine of theta, and multiplied by the sine of theta. The sine theta is reduced out, and we're left with cosine of theta. So that expression simplifies to the cosine of theta. What about this next one? When you see some things like this set up more of an algebraic idea, you want to just follow through with the algebra. Let's just multiply this stuff out. This is a difference of squares when multiplied out, so secant squared minus 1. When you see a secant squared, when you see a squared, you want to think, wait a second, I know those Pythagorean identities. What is secant squared equal to? Secant squared equals to the tangent squared plus 1. You can look back up at your notes right there. Tan squared plus 1 equals secant squared. And this will simplify to just tangent squared, and there's nothing else to do with that one. Let's go on to the next one. Now, on some of these, you might want to, there's different forms that we can use, and there's no one way that has to be done every time. If we follow along with what we did on the last one, we could say, oh, secant squared is the same as what? Secant squared is our tan squared. You want to try to remember those, and then we can distribute that across, and we get tan squared minus tan squared, which is just 0, and then negative 1. On the next one, well, there's a couple ways we can go about dealing with this. Number one, it's in terms of, we have secant, cosine, and we have a tangent, cotangent. One way to deal with it is to make them all in terms of sine, cosine. That's not the only way, but this is one way. So if I did that, I could say secant is 1 over cosine divided cosine minus sine over cosine divided by cosine over sine. Now we need to simplify this. So this would be, just to go over all those steps, some people have difficulty dividing fractions, so we have the top is going to be multiplied by the reciprocal of the bottom. So we have 1 over cosine minus sine over cosine times, multiplied by the reciprocal of the bottom, sine over cosine. So we get 1 over cosine squared minus sine squared over cosine squared. We have the same denominator here. So we have 1 minus sine squared over cosine squared. But what is 1 minus sine squared? Remember, we have sine squared plus cosine squared equals our 1. That's our main Pythagorean identity there. So if we solve for sine squared, or we actually solve for cosine squared, move that sine squared over, cosine squared is going to equal 1 minus sine squared. So what we can do there is just say cosine squared over cosine squared, and that equals 1. That's not the only way to deal with it. We can say, or, this one's a little bit more advanced, but I'll show it for those who can see this. This says secant times 1 over cosine. Well, that secant times 1 over cosine minus tangent times 1 over cotangent. Well, what is 1 over sine or cosine? That's secant. So this gives us secant squared. And what is 1 over cotangent? That's tangent. So this gives us tangent squared. And we know that 1 plus tangent squared, sorry you couldn't see that for a little bit, equals our secant squared. Or in other words, if we move the tangent squared to the other side, secant squared minus tan squared equals 1. And that's it. All right, the last one here. When I see something plus a fraction, one way to do this is I could combine them into one fraction. So this would be multiplying the top and bottom by tan A over tan A. So I would get tangent squared A plus 1 over tangent A. And then what I could do is, and now I have it all over tangent A. So we can do a couple things at one time. We have, this is tan squared plus 1. Remember our identity. Tan squared plus 1 is secant squared. So it's secant squared A over tan A times 1 over tangent A. Or in other words, secant squared A over tan squared A. Now, that doesn't look like it's completely simplified yet. What is secant squared? Secant squared is 1 over cosine squared times, now we're going to be multiplying by 1 over tan squared, which is the same as cotangent squared, or cosine squared over sine squared. The cosine squareds reduce out. I'm left with 1 over sine squared, which is cosecant squared of A. And that is it for our identities for this.